Today is 4.2. We're going to be talking about reflections. Another name for reflection is a flip. Okay? So, what I want you to do is look at those different terms. I want you to sketch out what you think or talk about what you think each of those mean, okay, based on what we've talked about or what you've seen in the past. Okay, give you a minute or two there, talk with your groupies about it. Okay, time's up. What is a reflection? Sam? Good, a mirror image of something. Okay? Of a figure. Very good. Mirror image of a figure. So when you look in a mirror, that is your reflection. A reflection is a rigid motion. Now, yesterday we didn't talk about rigid motion, but a rigid motion is something that maintains the size and the shape of the figure. The angle measures and the length of the sides do not change. So that might be something to add to your list, or at least go back to 4.1 and define it. Rigid motion maintains the length and angle measures. So the length of the sides and the angle measures. The shape does not change size. It does not change its shape. It's also called an isometry, but I don't think we ended up talking about it yesterday. A rigid motion maintains size and shape. Okay. We also call a rigid motion an isometry. All right, your line of symmetry. Well, actually, let's go back up here. We're at reflection. Okay, reflection is where you take and actually reflect a figure across the line. That line we call is our line of reflection. So if I had, say, the letter L, and I reflected it across this line, which we'll call the line of reflection, that would give me a backwards letter L. Notice the shape and the size does not change. Okay, the distance of this L, let me make a better line there. Okay. The distance of this L from this line is the same distance as this L from that line. So some things about reflections. If you were to take corresponding parts, so probably should fix my line a bit more. Didn't actually do a measured out reflection. Okay, if you were to look at corresponding parts and you were to actually connect those across that line of reflection, the line that connects them would be divided in half by the line of reflection, meaning that this piece of the line would be equal to that piece of the line. They'd be congruent parts, and they would cross at a right angle. Okay? So if you were to might be better actually highlight that a bit. Okay. That line right there, if you were to connect the corresponding pieces, that line would be cut in half and it would cross the line of reflection at a right angle. That still is not an amazing line. I don't think I've ever had so many problems with that. Let's say that point and that point. The distance right here, that distance is going to be congruent to this distance right here. And this line is going to intersect at a right angle. Okay? You guys actually see that color change up there? I cannot see it at all. It looks like that.
You're colorblind.
I'm serious. All right. All right.
Same thing.
Very good. Glide reflection. Glide reflection. We take a figure, for instance, our L. Everyone draw an L on your paper.
In a different color.
Okay? I want you to take that L now, and I want you to slide it. Okay, Moon or Carlo? Did I move you once already? Yes. So, hey, I'm not going to wonder every time I turn my head if you're talking. I'm just going to move you out of class. Then you can talk to Casper out there as you're writing paragraphs. Okay, we're not going to play that game in here. Okay? So, we can glide it. So glide is just a translation, what we did yesterday, right? So we now have our L.
We didn't even glide it.
Glide is like code for translation. If you want to think of it as a code, if that makes the math more fun. All right. Secret code word, translation. Okay? And then reflection is not a code word. It actually means reflect. You are reflecting. So now you actually have to reflect it. So let's say that's my line of reflection. I will now reflect my letter L across that line. I've got a glide reflection.
So gliding just means moving it?
Gliding means sliding it. Yeah. Translating it. Yes, sir.
I have a question about the line reflection.
Yeah.
So can it also reflect on the x-axis?
It could. Yeah. Yes, Danica. It's a name for a composition. Very good. Yeah, glide reflection is a composition. It's multiple things. All right. How many know what a line of symmetry is? How many know what line symmetry is? Line of symmetry and line symmetry, two different things. Okay, why don't you tell your neighbor what you think line symmetry and line of symmetry are.
No, but you just can't.
Okay, time's up. Let's say something can have line symmetry. Okay? So, name a letter that has line symmetry.
Oh,
Yes. Oh, okay, let's use something other than that. Yes. H. H has line symmetry. So here is my capital H. Now, my capital H has line symmetry. The line of symmetry is the line that it reflects across. So the line of symmetry for letter H is right there. Are there any other lines of symmetry? Yes, Jeremiah. Good. Cut in half that way as well. So it has two lines of symmetry. Pretty cool, huh? Find another letter that has line symmetry other than O. Write it on your paper there.
What about N? What about? Oh, I was going to say N.
All right.
N.
What other? Jeremiah? E? Abdul? A? Capitals, right? Yeah? T? Sam? W? U? Maddie? Yeah? M? Yes? I? V? K? See, there are a lot of them, right, Maddie? Yeah, we just keep going. Okay. Hold on, what'd you say? N? Nope, N doesn't. Yeah, you're just going with the no. Aha. Hey.
Wait, is this line symmetry or line of symmetry?
Don't do that. Lowercase n, no. Got a tail in. All right.
Yours is just one color. Yeah, I got some blue.
Okay, take a look at reflections. A reflection is a transformation that uses a line, like a mirror, to reflect the image. We call that a line of reflection. Notice point P is not on line M. Okay, and if a point is actually on the line, it reflects back to the line. So you're the same distance away from the line. So keep that in mind. This distance from here to here is the same as this distance from there to there. It crosses at a right angle. Okay. What I'd like you to do right now, yeah.
So wait, what's the difference between a line symmetry and a line of symmetry?
Something can have line symmetry. So like the letter H has line symmetry. The line of symmetry for letter H are those lines we've drawn in.
So they're kind of the same thing?
Nope, they're not kind of the same thing. So let's say I take the letter, letter T. Letter T has line symmetry.
Oh, line symmetry is stating correct that it has line symmetry.
Correct. The line of symmetry is the line. The line of reflection. Isaac.
Oh, you did that too. I wrote black and blue. I wrote the word black and blue.
No, they don't have to be parallel. Okay, Guys, I want you to take a look at page 100. Top of page 100. There you go. Read it to yourselves. All right, coordinate rules for reflections. If you have coordinate A and B, it's reflected across the x-axis. Notice the new coordinates will be A, negative B. If it's reflected across the y-axis, the new coordinates will be negative AB. You guys, one way to think about this, let me take a point. Okay, if I have this point right here, we'll call it, actually let's not use a negative to begin with. Let's start out with this point. We'll call that coordinate order pair 2, 3. Or excuse me, that's 3, 2. My goodness. 3, 2. Okay, and I want to reflect that across the y-axis. That's this axis right here. Okay, when I reflect it across the y-axis, is that point moving horizontally or is it moving vertically? It's moving horizontally. Even though I'm reflecting across y, it's moving horizontally. Therefore, what that means is the value that changes is my x value. The y value stays at the same level. Okay, therefore, we have the opposite of 3, which is negative 3, and 2. That's why when you have A, B, and you're reflecting across the y, this becomes opposite. Okay, you just make that value negative. Okay, or the opposite of what it was. Another way of saying negative is the opposite. And the same thing goes if I reflect across the x-axis. So now if I'm going this way, and I am moving this point downward, am I changing vertically or horizontally? Changing vertically. And vertically, the axis that measures vertically is your y-axis. Therefore, you're changing your y value. Okay? Jeremiah? You can, yeah. That would be a composition, though, if you reflect it over one axis and then the other. We'll talk about what that does when we do rotations. Okay? If AB is reflected over the line y equals x, y equals x. Everyone show your neighbor on a grid where y equals x is. For those of you who don't know, is this line right here. 1, 1, 0, or 2, 2, 3, 3, 4, 4, 5, 5, and so on. It is that diagonal that goes that way. If I reflect across that diagonal, remember this point that was here, it has to cross at a right angle. It moves in that direction. Okay? Now we could do a bunch of these and explore it, but really what happens is your B and A switch. What was B, was your x value, is now your y value. And what was your y value is now your x value. That goes to the order pair 2 and 3. So x and y switch when you reflect across y equals x. And if you reflect across y equals negative x, that's this line. Not an amazing one, but okay. We reflect across that line. What ends up happening is this point, once again, has to move in a direction where if I were to connect it to its reflected point, it would cross at a right angle. So from here, it would drop down to right around there somewhere. And you would now be at negative BA. So what was x becomes y, and you make them negative. Negative B, negative A. So I had 3, 2. I now need to make it 2, 3, and change them both to negatives. Now my line was off a bit, because that should actually be negative 3. So I took a big jump down there. But if you're using a grid, it would actually work out perfectly there. Problem with drawing our own grid. Okay, so just some things to kind of keep in mind when you're doing this. A lot of these reflections we're going to be doing on grids. But it's a good way to check. So reference back to this a lot when we're doing our assignment today. All right, so you guys are starting to tune out. What I need you to do is look at page 100. I want you to complete problems 1 and 3. Okay? Problems 1 and 3 on 100.
1 and 3 or 1?
1 and 3. Off you go. Okay, so the first thing you need to do is think about what you should go up by, right?
I'm just drawing extra line. I want to go up by 1.
You want to go up by ones? You go up by ones. If it fits. If it fits, go up by ones. If it doesn't fit, go up by 2. Maybe 3. I think it might fit with ones, though, doesn't it?
Now we
No?
reflect it.
I just go to 5.
Oh. So you have to go up by 2s then. Okay. Oh, sheesh. Poor 2. That's odd. Actually, it's even.
Yeah.
All right, I decided to go up by 2 on both axes. That is what I have right there.
You said 1 and 3.
I know I said 1 and 3. Will you calm down? Breathe. Breathe.
Oh,
You're chewing on something. You might
wait.
accidentally inhale.
Why does mine
I'll have
look
to give you the
different than
Heimlich
yours?
maneuver. Breathe. It's
No,
okay.
Maddie, I'm not
Okay, so we got 1. I'm going to be walking around. If you struggle with it, make sure you call me over. Now, you can try number, which one, Maddie? Number 3.
Should you put it on the dose?
No, you don't have to do number 2. Okay, we'll come back to 2. I want you to try 3.
What is this? I need 9.
Hey, how many of you have set up your scale? What are you going up by?
No.
You're going up by ones?
Yes.
Does it fit?
Yes.
You sure?
Yes. It's a skinny one. It's a skinny
Okay. So let me tell you that y equals 1 before you get going too far. Everyone find 1 on your y-axis. Come on now. You guys, on this previous problem, we reflected across this axis right here. That is the y-axis. Now what confuses students is they're like, oh yeah, the y-axis moves like that. That's good. And then they go to y equals 1. Well, y equals 1 is right here. It is right here. That is y equals 1. Okay? So keep in mind when you are reflecting across a line, y equals, it crosses the y-axis at that point and then extends out. That is y equals 1. That is your line of reflection. Okay, it's kind of counterintuitive what you think. You're like, hold on, y equals, that's a vertical line. That's why I had you do 1 and 3 first. Okay. I don't know. So now do you have to change your scale?
Yes.
Yes, you have to change your scale. Sorry now.
No, I'm not changing mine.
Forget it. I'm not doing it. Yeah, you guys be rebels. Okay. All right. Hey guys, when you're reflecting like this, if I try, I need everyone to pause for a minute. If I try to plot this, is it going to fit on here? How many have done this? How many have plotted the point? Okay. Does it fit? Yeah? So at y equals 1, let me plot my points. I'm going to go 2, -1, -4, -2, -1, -3. Correct? Okay. All right. This was my A, my B, and my C. All right. When I reflect across the line y equals 1, A is 2 units away from the line. Therefore, it's going to have to be 2 units away up here. That is A prime. Is it going to fit?
I thought it was going from this line up and not.
C is 1, 2, 3, 4 units away. 1, 2, 3, 4. It doesn't quite fit. So as Alex just said, hey, you got to draw an extra line up there. And B, 1, 2, 3, 1, 2, 3. Now you guys have your hands up. What's up?
So do you have to change? So when you change your scale,
Yep.
like you know how ours is y equals 1.
Correct.
If we change our scale, does y equals 1 have to be in a different spot?
Yes, very good point. So if you change your scale, does y equal 1 have to go to a different spot? Yes, it does, because y equals 1 is no longer there. So if you said I'm going up by 2s, then y equals 1 is right here. Lexus. Yeah, so you were using this. That's if you reflect across the line y equals x. Right? So we're reflecting across the line y equals 1. So you can't, these won't apply here. You've got to actually plot them. Okay? All right. Okay, I want you to try number 2. Reflect across the x-axis. All right. Here you go. That is number 2. That one, I went up by 2s again. So you got. I really think it's going to be best for you to make your intervals 2 on all these.
I just went up by 1 and Jordan has 1. That's still okay.
Maybe on that one. Okay. Any questions on that one? I want you to give the next one a go. Number 4. I will tell you have to change your scale on that one. So once again, x equals -3 is this line. So if I go up, make this 8, make that 8, and I'm going up by 2s, x equals -3, I'm at x equals -2, x equals -3 is right here.
Did you change your scale
Okay.
to?
Crosses the x-axis at -3.
Wait, what was the trail scale? The trail. What's it called? The scale changed to?
2, 4, 6, 8. So going up by 2s. When I reflect, there's A prime, same distance away. B prime, same distance away. And C prime, same distance away. Reflected. So our image and our pre-image. So pre-image, image there. Okay, how many got it? All right, questions? Take a breath. No. All right, next page. Go ahead and take a look at number 5, please. Number 5, in exercise 5 and 6, graph the polynomials after the reflection in the given line. First thing, I want you to draw the given line.
It's right there.
So y equals x, remember, is this line right here.
Oh my gosh.
I know. If you're doing that one, remember,
What about the other way?
the other way is y equals negative. So you think y is 1, x is 1. Y is 2, x is 2. Y is 3, x is 3. Always the same. Versus the other way, which is y equals negative x. When y is 1, x is negative 1. Reflect our line. All right, go ahead and check your work here. Numbers 5 and number 6 Rue. Okay, I'm going to come around and help out if you need. Can I have your attention up here? You guys, make sure that you know on this one, when I reflect point B, remember the coordinates for B are -1, 2. So the new coordinates are going to be, I don't have my sheet for me. If you're looking at this top part, when you're reflecting across y equals x, you just flip them around. So what you had for negative 1, 2 is now 2, negative 1. And if you were to connect these points, a good check, connect the points. They should cross at a right angle, and they should be equidistant away from each other, or from the line of reflection. Yeah?
On the number 6,
Uh-huh.
wouldn't C prime be D prime?
C prime. Oh, yeah, I have this mislabeled. Yes, this would be D prime. Thank you for pointing that out. Yeah, you will. Good job. Okay, I got your assignment here. We're going to finish that page later.
No.